We're going to continue our study of combination and permutation, and we're going to review a couple of things we've covered. So the first thing we'll talk about is the very first method we covered, which is the counting principle, or we'll call it slots for short. This is going to be your go-to method, and this is really good because, I'll put a star here, it can handle advanced problems. Like, it's really good at handling all kinds of problems. It's probably your strongest method available to you. Now within this realm, we also have the repeated elements formula. That's what we covered in the last class. And that's your n factorial over a factorial, b factorial, c factorial, dot, dot, dot. N is your total, and the things on the bottom, that's your repeated elements. And then on the right side, you have kind of your rigid formulas. We have the permutation formula. And the permutation formula is NPR, that's n factorial over n minus r factorial. For permutation, order matters, and your elements can't repeat. And then we also have the combination formula. And combination formula is NCR, that's n factorial over n minus r factorial, r factorial. And for this one, order does not matter. And again, elements cannot repeat. And we also have our circular permutation. We should probably review that too. We'll put that over here. Circular permutation. So what to do if it's a circle? That's n factorial or n minus 1 factorial. That's a review of all the methods we have, right? We have this one, repeated elements, permutation, combination. So counting principle is again going to be your go-to, and then the next couple are going to be a little more rigid. And I put these on this side because these formulas are kind of like special cases. Like especially this one, permutation formula, you'll see that it's not super useful. We use a little bit today. This is only good for circles, and this is only good for like combination problems. But we're going to use a whole bunch today. So first thing, it says for each of the following problems, determine whether the problem is one involving permutation or combination. Do not solve. So we actually are going to solve it, but we're going to use our calculator. So make sure you have your calculator ready. I'm going to show you how to use your calculator today to save us some time. So first question. 6 students are running for student government, president, vice president, treasurer. That's important. Let's highlight that. President, VP, treasurer. Okay, the student, the greatest number of votes becomes president, and so on. And it says how many different outcomes are possible for these 3 positions. So immediately notice that these are talking about 3 separate positions, which would mean order matters. Which means it's going to be a permutation problem. So we could use slots, but we can also use our permutation formula. Because we're working with people, so clearly people can't repeat, so the answer is going to be simply 6p3. Because there are 6 people running and only 3 positions. Now for your calculator, it's pretty easy to do this. Hit the toolbox right here. Make sure you highlight it on math there. So again, toolbox, and make sure math is the thing you're hitting here. Then go to permutation, and you're going to put 6, 3. That's 6p3, and there's your answer, 120. B, 6 people are on the board, a 3-person committee. Make sure you highlight the word committee, that's huge. How many committees are possible? So remember, as soon as you see the word committee, that's going to be combination. So we're going to write there are 6 people, combination, and 3. So let's go back to our calculator. Same process, except this time you hit combination. 6, 3. There it is, 20. Next one. Baskin Robbins offers 31 different flavors. One of its items is a bowl consisting of 3 scoops of ice cream. How many such bowls are possible? So since it's ice cream, and it looks like, yeah, each is a different flavor. That's important. So once you use vanilla, you can't use vanilla anymore. This is clearly a combination because order wouldn't matter here. So we're going to put 31C3. Let's go back. Same process. There it is. Okay, now I'll try a couple of harder ones. A chef has 5 brands of hot sauce. 3 of the brands will be chosen to mix into gumbo. How many outcomes are possible? So hopefully you see this is clearly combination. So 5C3, type it into your calculator, you get 10. This is kind of a weird question. It's an ice cream question, except it is important to you which flavor goes on top, middle, and bottom, which means order does matter. So we're going to do a permutation here, and we're going to type in 15p3, put that in your calculator, you get 2,730. Now here are the ones that are going to be a little more difficult. 4 Democrats, 5 Republicans on the county commission. From among their group, they will choose a committee of 2 Democrats and 2 Republicans. How many 4-person groups are possible? So clearly this is a combination problem. But notice how it's advanced. It's not simple like the earlier ones. Within the combination, like within a committee, there's a subgroup of Democrats and Republicans. So to do this, we actually have to do our slots method. The first slot is going to represent the Democrats, and the second slot is the Republicans, because you're choosing from those 2 groups of people. Now, what makes it advanced is in the Democrats, we can only choose 2 out of the 4. So in that slot, you write 4, choose 2. And then from the Republicans, we can only choose 2 out of the 5. So 5, choose 2. So in your calculator, you put that in. We're going to do 4, 2 times 5, 3. Answer is 60. Now here's the last one. Asher has been chosen to be in the halftime show at a basketball game. He has been told that he's allowed to bring 1, 2, or 3 of his friends to compete with him. If Asher is with 8 friends, how many different combinations of friends could he take to play? So this is kind of complicated because there are multiple cases happening here. There's case 1, he grabs 1 friend. Case 2, he brings 2 friends. And there's case 3, he brings 3 friends. So we're going to just calculate each case, and we'll talk about what to do after that. Okay, so let's say he brings 1 friend. How many ways could he do that? Well, he has 8 friends, and how many ways can he pick 1 of them? So that'd be 8C1. Now go to case 2. He can pick 2 of them. So how many ways can he pick 2 friends? Well, that'd be 8C2. And then he has 3 friends. How many ways could he bring 3 friends? Well, that would be 8C3. And the question is, how many combinations of friends could he take to play? So we're going to take each of these individual cases and we're going to add them, because that's how we're going to get our total, right? We're adding the separate cases. So let's go to our calculator. Let's figure that out. Okay, 92. Now there's our answer. Now you have to notice the difference between this one and this problem. In this problem, notice how we multiply, because this is one situation. In the one situation we're given, we're mixing these two groups of people, so we have to multiply it. However, in this one, these are three separate scenarios. So in that situation, to combine all of it, we have to add them because they're entirely separate scenarios, like independent of each other. All right, now good luck on the rest of the questions. Let me know if you get stuck on any.